A security alarm is a system designed to detect intrusion unauthorized entry into a building or area. Security alarms are used in residential, commercial, industrial, and military properties for protection against burglary or property damage, as well as personal protection against intruders. Car alarms likewise protect vehicles and their contents. Prisons also use security systems for control of inmates. Some alarm systems serve a single purpose of burglary protection. Combination systems provide both fire and intrusion protection. Intrusion alarm systems may also be combined with closed-circuit television surveillance systems to automatically record the activities of intruders, and may interface to access control systems for electrically locked doors. Systems range from small, self-contained noisemakers, to complicated, multi-area systems with computer monitoring and control. Design. The most basic alarm consists of one or more sensors to detect intruders, and an alerting device to indicate the intrusion. However, a typical premises security alarm employs the following components: premises control unit, or panel, the brain of the system. It reads sensor inputs, tracks arm-disarm status, and signals intrusions. In modern systems, this is typically one or more computer circuit boards inside a metal enclosure, along with a power supply. Sensors, devices which detect intrusions. Sensors may be placed at the perimeter of the protected area, within it, or both. Sensors can detect intruders by a variety of methods, such as monitoring doors and windows for opening, or by monitoring unoccupied interiors for motions, sound, vibration, or other disturbances. Alerting devices, these indicate an alarm condition. Most commonly, these are bells, sirens, and/or flashing lights. Alerting devices serve the dual purposes of warning occupants of intrusion, and potentially scaring off burglars. These devices may also be used to warn occupants of a fire or smoke condition. Keypads, small devices, typically wall-mounted, which function as the human-machine interface to the system. In addition to buttons, keypads typically feature indicator lights, a small multi-character display, or both. Interconnections between components. This may consist of direct wiring to the control unit, or wireless links with local power supplies. Security devices, devices to detect thieves such as spotlights, cameras and lasers. In addition to the system itself, security alarms are often coupled with a monitoring service. In the event of an alarm, the premises control unit contacts a central monitoring station. Operators at the station see the signal and take appropriate action, such as contacting property owners, notifying police, or dispatching private security forces. Such signals may be transmitted via dedicated alarm circuits, telephone lines, or Internet. Sensor types, passive infrared detectors. The passive infrared motion detector is one of the most common sensors found in household and small business environments. It offers affordable and reliable functionality. The term passive refers to the fact that the detector does not generate or radiate its own energy. It works entirely by detecting the heat energy given off by other objects. Strictly speaking, PIR sensors do not detect motion. Rather, they detect abrupt changes in temperature at a given point. As an intruder walks in front of the sensor, the temperature at that point will rise from room temperature to body temperature, and then back again. This quick change triggers the detection. PIR sensors may be designed to be wall or ceiling mounted, and come in various fields of view, from narrow point detectors to 360-degree fields. PIRs require a power supply in addition to the detection signaling circuit. Ultrasonic detectors, using frequencies between 15 kHz and 75 kHz, these active detectors transmit ultrasonic sound waves that are inaudible to humans. The Doppler shift principle is the underlying method of operation, in which a change in frequency is detected due to object motion. This is caused when the object must cause a change in the ultrasonic frequency to the receiver relative to the transmitting frequency. The ultrasonic detector operates by the transmitter emitting an ultrasonic signal into the area to be protected. the sound waves are reflected by solid objects and then detected by the receiver. Because ultrasonic waves are transmitted through air, then hard-surfaced objects tend to reflect most of the ultrasonic energy, while soft surfaces tend to absorb most energy. When the surfaces are stationary, the frequency of the waves detected by the receiver will be equal to the transmitted frequency. However, a change in frequency will occur as a result of the Doppler principle, when a person or object is moving towards or away from the detector. Such an event initiates an alarm signal. This technology is considered obsolete by many alarm professionals, and is not actively installed. Microwave detectors. This device emits microwaves from a transmitter and detects any reflected microwaves or reduction in beam intensity using a receiver. The transmitter and receiver are usually combined inside a single housing for indoor applications, and separate housings for outdoor applications. To reduce false alarms, this type of detector is usually combined with a passive infrared detector or Dirac alarm. Microwave detectors respond to a Doppler shift in the frequency of the reflected energy, by a phase shift, or by a sudden reduction of the level of received energy. Any of these effects may indicate motion of an intruder. Photoelectric beams. Photoelectric beam systems detect the presence of an intruder by transmitting visible or infrared light beams across an area, where these beams may be obstructed. To improve the detection surface area, the beams are often employed in stacks of 2 or more. However, if an intruder is aware of the technology's presence, it can be avoided. The technology can be an effective long-range detection system, if installed in stacks of 3 or more where the transmitters and receivers are staggered to create a fence-like barrier. Systems are available for both internal and external applications. To prevent a clandestine attack using a secondary light source being used to hold the detector in a sealed condition whilst an intruder passes through, most systems use and detect a modulated light source. Glass break detection. The glass break detector may be used for internal perimeter building protection. Glass break acoustic detectors are mounted in close proximity to the glass panes and listen for sound frequencies associated with glass breaking. Seismic glass break detectors, generally referred to as shock sensors, are different in that they are installed on the glass pane. When glass breaks, it produces specific shock frequencies which travel through the glass and often through the window frame and the surrounding walls and ceiling. Typically, the most intense frequencies generated are between 3 and 5 kHz, depending on the type of glass and the presence of a plastic interlayer. Seismic glass break detectors are these shock frequencies and in turn generate an alarm condition. Window foil is a less sophisticated, mostly outdated, detection method that involves gluing a thin strip of conducting foil on the inside of the glass and putting low-power electrical current through it. Breaking the glass is practically guaranteed to tear the foil and break the circuit. Smoke, heat, and carbon monoxide detectors. Most systems may also be equipped with smoke, heat, and/or carbon monoxide detectors. These are also known as 24-hour zones. Smoke detectors and heat detectors protect from the risk of fire, and carbon monoxide detectors protect from the risk of carbon monoxide. Although an intruder alarm panel may also have these detectors connected, it may not meet all the local fire code requirements of a fire alarm system. Traditional smoke detectors are technically ionization smoke detectors which create an electric current between 2 metal plates, which sound an alarm when disrupted by smoke entering the chamber. Ionization smoke alarms can quickly detect the small amounts of smoke produced by fast-flaming fires, such as cooking fires or fires fueled by paper or flammable liquids. A newer, and perhaps safer type is a photoelectric smoke detector. It contains a light source in a light-sensitive electric sensor, which is positioned at a 90-degree angles to the sensor. Normally, light from the light source shoots straight across and misses the sensor. When smoke enters the chamber, it scatters the light, which then hits the sensor and triggers the alarm. Photoelectric smoke detectors typically respond faster to a fire in its early, smoldering stage before the source of the fire bursts into flames. Vibration or inertia sensors. These devices are mounted on barriers and are used primarily to detect an attack on the structure itself. The technology relies on an unstable mechanical configuration that forms part of the electrical circuit. When movement or vibration occurs, the unstable portion of the circuit moves and breaks the current flow, which produces an alarm. The technology of the devices varies and can be sensitive to different levels of vibration. The medium transmitting the vibration must be correctly selected for the specific sensor, as they are best suited to different types of structures and configurations. A rather new and unproven type of sensor uses piezoelectric components rather than mechanical circuits, which can be tuned to be extremely sensitive to vibration. Pros: very reliable sensors, low false alarm rate and middle place in the price range. Cons: must be fence-mounted. The rather high price deters many customers, but its effectiveness offsets its high price. Piezoelectric sensors are a new technology with an unproven record as opposed to the mechanical sensor, which in some cases has a field record in excess of 20 years. Passive magnetic field detection: this buried security system is based on the magnetic anomaly detection principle of operation. The system uses an electromagnetic field generator powered by two wires running in parallel. Both wires run along the perimeter and are usually installed about 5 inches/12 cm apart on top of a wall, or about 12/30 cm below ground. The wires are connected to a signal processor which analyzes any change in the magnetic field. This kind of buried security system's sensor cable could be embedded in the top of almost any kind of wall to provide a regular wall detection ability, or can be buried in the ground. They provide a very low false alarm rate, and have a very high chance of detecting real burglars. However, they cannot be installed near high-voltage lines, or radar transmitters. E-field: this proximity system can be installed on building perimeters, fences, and walls. It also has the ability to be installed freestanding on dedicated poles. The system uses an electromagnetic field generator powering one wire, with another sensing wire running parallel to it. Both wires run along the perimeter and are usually installed about 800 mm apart. The sensing wire is connected to a signal processor that analyses amplitude change, rate change, preset disturbance time. These items define the characteristics of an intruder, and when all three are detected simultaneously, an alarm signal is generated. The barrier can provide protection from the ground to about 4 meters of altitude. It is usually configured in zones of about 200-meter lengths depending on the number of sensor wires installed. Advantage: concealed as a buried form. Disadvantage: expensive, short zones, which mean more electronics, high rate of false alarms as it cannot distinguish a cat from a human. In reality it does not work that well, as extreme weather causes false alarms. Microwave barriers: the operation of a microwave barrier is very simple. This type of device produces an electromagnetic beam using high-frequency waves that pass from the transmitter to the receiver, creating an invisible but sensitive wall of protection. When the receiver detects a difference of condition within the beam, the system begins a detailed analysis of the situation. If the system considers the signal a real intrusion, it provides an alarm signal that can be treated in analog or digital form. Advantage: low cost, easy to install, invisible perimeter barrier, and known perimeter limits to the intruder. Disadvantage: extremely sensitive to weather, as rain, snow and fog for example would cause the sensors to stop working. Need sterile perimeter line because trees, bushes or anything that blocks the beam would cause false alarm or lack of detection. Microphonic systems: microphonic-based systems vary in design, but each is generally based on the detection of an intruder attempting to cut or climb over a chain wire fence. Usually the microphonic detection systems are installed as sensor cables attached to rigid chain wire fences. However, some specialized versions of these systems can also be installed as buried systems underground. Depending on the version selected, it can be sensitive to different levels of noise or vibration. The system is based on coaxial or electromagnetic sensor cable, with the controller having the ability to differentiate between signals from the cable or chain wire being cut, an intruder climbing the fence, or bad weather conditions. The systems are designed to detect and analyze incoming electronic signals received from the sensor cable, and then to generate alarms from signals which exceed preset conditions. The systems have adjustable electronics to permit installers to change the sensitivity of the alarm detectors to the suit's specific environmental conditions. The tuning of the system is usually accomplished during commissioning of the detection devices. Advantage: very cheap, very simple configuration, easy to install. Disadvantage: some systems have a high rate of false alarms because some of these sensors might be too sensitive. Although systems using DSP will largely eliminate false alarms on some cases. Taut wire fence systems. A taut wire perimeter security system is basically an independent screen of tension tripwires usually mounted on a fence or wall. Alternatively, the screen can be made so thick that there is no need for a supporting chainwire fence. These systems are designed to detect any physical attempt to penetrate the barrier. Taut wire systems can operate with a variety of switches or detectors that sense movement at each end of the tensioned wires. These switches or detectors can be a simple mechanical contact, static force transducer or an electronic strain gauge. Unwanted alarms caused by animals and birds can be avoided by adjusting the sensors to ignore objects that exert small amounts of pressure on the wires. This type of system is vulnerable to intruders digging under the fence. A concrete footing directly below the fence is installed to prevent this type of attack. Pros: low rate of false alarms, very reliable sensors and high rate of detection. Cons: very expensive, complicated to install and old technology. Fiber optic cable. A fiber optic cable can be used to detect intruders by measuring the difference in the amount of light sent through the fiber core. If the cable is disturbed, light will leak out and the receiver unit will detect a difference in the amount of light received. The cable can be attached directly to a chainwire fence or bonded into a barbed steel tape that is used to protect the tops of walls and fences. This type of barbed tape provides a good physical deterrent as well as giving an immediate alarm if the tape is cut or severely distorted. Other types work on the detection of change in polarization which is caused by fiber position change. Advantage: very similar to the microphonic system, very simple configuration, easy to install. Disadvantage: high rate of false alarm or no alarms at all for systems using light that leaks out of the optical fiber. The polarization changing system is much more sensitive but false alarms depend on the alarm processing. H-field. This system employs an electromagnetic field disturbance principle based on two unshielded coaxial cables buried about 10–15 cm deep and located at about 1 meter apart. The transmitter emits continuous radio frequency energy along one cable and the energy is received by the other cable. When the change in field strength weakens due to the presence of an object and reaches a preset lower threshold, an alarm condition is generated. The system is unobtrusive when it has been installed correctly, however care must be taken to ensure the surrounding soil offers good drainage in order to reduce nuisance alarms. Pros: concealed as a buried form. Cons: can be affected by RF noise, high rate of false alarms, hard to install. Wired, wireless and hybrid systems. The trigger signal from every sensor is transmitted to one or more control unit, either through wires or wireless means. Wired systems are convenient when sensors require power to operate correctly, however, they may be more costly to install. Entry-level wired systems utilize a star network topology, where the panel is at the center logically, and all devices home run its wire back to the panel. More complex panels use a bus network topology where the wire basically is a data loop around the perimeter of the facility, and has drops for the sensor devices which must include a unique device identifier integrated into the sensor device itself. Wired systems also have the advantage, if wired properly, of being tamper-evident. Wireless systems, on the other hand, often use battery-powered transmitters which are easier to install and have less expensive startup costs, but may reduce the reliability of the system if the batteries are not maintained. Depending on distance and construction materials, one or more wireless repeaters may be required to get the signal to the alarm panel reliably. A wireless system can be moved to a new home easily, an advantage for those who rent or who move frequently. The more important wireless connection for security is the one between the control panel and the monitoring station. Wireless monitoring of the alarm system protects against a burglar cutting a cable or from failures of an internet provider. This full wireless setup is commonly referred to as 100% wireless. Hybrid systems use both wired and wireless sensors to achieve the benefits of both. Transmitters, or sensors, can also be connected through the premises' electrical circuits to transmit coded signals to the control unit. The control unit usually has a separate channel or zone for burglar and fire sensors, and better systems have a separate zone for every different sensor, as well as internal trouble indicators. Alarm connection and monitoring. Depending upon the application, the alarm output may be local, remote, or a combination. Local alarms do not include monitoring, though may include indoor and/or outdoor sounders and lights, which may be useful for signaling an evacuation notice for people during fire alarms, or where one hopes to scare off an amateur burglar quickly. However, with the widespread use of alarm systems, false alarms are very frequent, and many urbanites tend to ignore alarms rather than investigating, let alone contacting the necessary authorities. In short, there may be no response at all. In rural areas, lights or sounds may not make much difference anyway, as the nearest responders could take so long to get there that nothing can be done to avoid losses. Remote alarm systems are used to connect the control unit to a predetermined monitor of some sort, and they come in many different configurations. High-end systems connect to a central station or responder via a direct phone wire, a cellular network, a radio network, or an IP path. In the case of a dual signaling system, two of these options are utilized simultaneously. The alarm monitoring includes not only the sensors, but also the communication transmitter itself. While direct phone circuits are still available in some areas from phone companies, because of their high cost and the advent of dual signaling with its comparatively lower cost, they are becoming uncommon. Direct connections are now most usually seen only in federal, state, and local government buildings, or on a school campus that has a dedicated security, police, fire, or emergency medical department. More typical systems incorporate a digital cellular communication unit that will contact the central station via the public switched telephone network and raise the alarm either with a synthesized voice or increasingly via an encoded message string that the central station decodes. These may connect to the regular phone system on the system side of the demarcation point, but typically connect on the customer side ahead of all phones within the monitored premises so that the alarm system can seize the line by cutting off any active calls and call the monitoring company if needed. A dual signaling system would raise the alarm wirelessly via a radio path or cellular path using the phone line or broadband line as a backup, overcoming any compromise to the phone line. Encoders can be programmed to indicate which specific sensor was triggered, and monitors can show the physical location of the sensor on a list or even a map of the protected premises, which can make the resulting response more effective. For example, a heat sensor alarm, coupled with a flame detector in the same area, is a more reliable indication of an actual fire than just one or the other sensor indication by itself. Many alarm panels are equipped with a backup communication path for use when the primary PSTN circuit is not functioning. The redundant dialer may be connected to a second communication path, or a specialized encoded cellular phone, radio, or internet interface device to bypass the PSTN entirely, to thwart intentional tampering with the phone line. Just the fact that someone tampered with the line could trigger a supervisory alarm via the radio network, giving early warning of an imminent problem. In some cases, a remote building may not have PSTN phone service, and the cost of trenching and running a direct line may be prohibitive. It is possible to use a wireless cellular or radio device as the primary communication method. In the UK, the most popular solution of this kind is similar in principle to the above, but with the primary and backup paths reversed. Utilizing a radio path as the primary signaling path is not only quicker than PSTN but also allows huge cost savings, as unlimited amounts of data can be sent at no extra expense. Broadband alarm monitoring. Increasing deployment of voice-over IP technology is driving the adoption of broadband signaling for alarm reporting. Many sites requiring alarm installations no longer have conventional telephone lines, and alarm panels with conventional telephone dialer capability do not work reliably over some types of VoIP service. Dial-up analog alarm panels or systems with serial parallel data ports may be migrated to broadband through the addition of an alarm server device which converts telephone signaling signals or data port traffic to IP messages suitable for broadband transmission. But the direct use of VoIP to transport analog alarms without an alarm server device is problematic, as the audio codecs used throughout the entire network transmission path cannot guarantee a suitable level of reliability or quality of service acceptable for the application. In response to the changing public communications network, new alarm systems often can use broadband signaling as a method of alarm transmission, and manufacturers are including IP reporting capability directly in their alarm panel products. When the Internet is used as a primary signaling method for critical security and life safety applications, frequent supervision messages are configured to overcome concerns about backup power for network equipment and signal delivery time. But for typical applications, connectivity concerns are controlled by normal supervision messages, sent daily or weekly. Various IP alarm transmission protocols exist, but most in use today are proprietary. Just as the formats used for conventional telephone reporting were standardized and published, broadband signaling for alarm reporting is being standardized today. In 2007, U.S. alarm manufacturers developed an open standard called DC-09. This standard has been accepted as an American national standard, and is published as ANSI DC-09-2007. Ref. ANSI DC-09-2007, the protocol provides an encoding scheme and transport mechanism to carry data from 17 previously defined alarm protocols, including the latest Contact ID, SIA-DC-03 and SIA-2000 protocols. Ref. ANSI DC-07-2001.04. Several manufacturers of panels and receivers are reported to be developing or have released support for DC-09. Radio alarm dual signaling. Dual signaling is a method of alarm transmission that uses a mobile phone network and a telephone and/or IP path to transmit intruder, fire and personal attack signals at high speed from the protected premises to an alarm receiving center. It most commonly uses GPRS or GSM, a high-speed signaling technology used to send and receive Euro packets, Euro unregistered trademark of data, with a telephone line in addition. The option of IP is not used as frequently due to issues with installation and configuration, as a high level of IT expertise is often required in addition to alarm installation knowledge. A dual signaling communication device is attached to a control panel on a security installation and is the component that transmits the alarm to the ARC. It can do this in a number of different ways, via the GPRS radio path, via the GSM radio path, or via the telephone line or IP if that has been chosen. These multiple signaling paths are all present and live at the same time, backing each other up to minimize exposure of the property to intruders. Should one fail, there is always one form of backup, and depending on the manufacturer, chosen up to 3 paths working simultaneously at any one time. Prior to the availability of dual signaling systems, police and car-holders were often called out to the premises because of an alarm signal on the telephone path, only to discover that it was a network fault and not a genuine alarm. Dual paths allow distinction between hardware failures and a genuine attack on the alarm. This helps eliminate false alarms and unnecessary responses. Dual signaling has helped considerably with the restoration of police responses in an instance where a phone line is cut, as the dual signaling device can continue to send alarm calls via one of its alternative paths, either confirming or denying the alarm from the initial path. In the UK, CSL Dualcomm Limited pioneered dual signaling in 1996. In doing so, the company offered the first credible alternative to existing alarm signaling while setting the current standard for professional dual-path security monitoring. Dual signaling is now firmly regarded as the standard format for alarm signaling and is duly specified by all of the leading insurance companies. Listen-in alarm monitoring. Monitored alarms and speaker phones allow for the central station to speak with a homeowner or intruder. This may be beneficial to the owner for medical emergencies. For actual break-ins, the speaker phones allow the central station to urge the intruder to cease and desist as response units have been dispatched. Listen-in alarm monitoring is also known as immediate audio response monitoring or speaking alarm systems in the UK. Alarm monitoring services. The list of services to be monitored at a central station has expanded over the past few years to include access control, CCTV monitoring, alarm verification, environmental monitoring, intrusion alarm monitoring, fire alarm and sprinkler monitoring, critical condition monitoring, medical response monitoring, elevator telephone monitoring, hold-up or panic alarm monitoring, duress monitoring, auto dialer tests, open and close signal supervision and reporting, exception reports, and PIN or passcode management. Increasingly, the central stations are making this information available directly to end users via the Internet and a secure log-on to view and create custom reports on these events themselves. Alarm response. In the United States, police respond to at least 36 million alarm activations each year, at an estimated annual cost of $1.8 billion. Depending upon the zone triggered, number and sequence of zones, time of day, and other factors, the Alarm Monitoring Center may automatically initiate various actions. Central station operators might be instructed to call emergency services immediately, or to first call the protected premises or property manager to try to determine if the alarm is genuine. Operators could also start calling a list of phone numbers provided by the customer to contact someone to go check on the protected premises. Some zones may trigger a call to the local heating oil company to go check on the system, or a call to the owner with details of which room may be getting flooded. Some alarm systems are tied to video surveillance systems so that current video of the intrusion area can be instantly displayed on a remote monitor, not to mention recorded. Some alarm systems use real-time audio and video monitoring technology to verify the legitimacy of an alarm. In some municipalities around the United States, this type of alarm verification allows the property it is protecting to be placed on a verified response list, allowing for quicker and safer police responses. The first video home security system was patented on December 2, 1969 to inventor Marie Brown. The system used television surveillance, access control and bypass codes. To be useful, an intrusion alarm system is deactivated or reconfigured when authorized personnel are present. Authorization may be indicated in any number of ways, often with keys or codes used at the control panel or a remote panel near an entry. High-security alarms may require multiple codes, or a fingerprint, badge, hand geometry, retinal scan, encrypted response generator, and other means that are deemed sufficiently secure for the purpose. Failed authorizations should result in an alarm or at least a timed lockout to prevent experimenting with possible codes. Some systems can be configured to permit deactivation of individual sensors or groups. Others can also be programmed to bypass or ignore individual sensors and leave the remainder of the system armed. This feature is useful for permitting a single door to be opened and closed before the alarm is armed, or to permit a person to leave, but not return. High-end systems allow multiple access codes, and may even permit them to be used only once, or on particular days, or only in combination with other users' codes. In any case, a remote monitoring center should arrange an oral code to be provided by an authorized person in case of false alarms, so the monitoring center can be assured that a further alarm response is unnecessary. As with access codes, there can also be a hierarchy of oral codes, say, for furnace repair person to enter the kitchen and basement sensor areas but not the silver vault in the butler's pantry. There are also systems that permit a duress code to be entered and silence the local alarm, but still trigger the remote alarm to summon the police to a robbery. Fire sensors can be isolated, meaning that when triggered, they will not trigger the main alarm network. This is important when smoke and heat is intentionally produced. The owners of buildings can be fined for generating false alarms that waste the time of emergency personnel. False/no alarms. The United States Department of Justice estimates that between 94% and 98% of all alarm calls to law enforcement are false alarms. System reliability and user error are the cause of most false alarms, sometimes called nuisance alarms. False alarms can be very costly to local governments, local law enforcement, security system users and members of local communities. In 2007, the Department of Justice reported that in just 1 year, false alarms cost local municipalities and their constituents at least $1.8 billion. In many municipalities across the United States, policies have been adopted to fine home and business owners for multiple false alarm activations from their security system. If multiple false alarms from the same property persist, that property could even be added to a no-response list, which bars police dispatch to the property except in the event of verified emergency. Approximately 1% of police alarm calls actually involve a crime. Nuisance alarms occur when an unintended event evokes an alarm status by an otherwise properly working alarm system. A false alarm also occurs when there is an alarm system malfunction that results in an alarm state. In all three circumstances, the source of the problem should be immediately found and fixed, so that responders will not lose confidence in the alarm reports. It is easier to know when there are false alarms, because the system is designed to react to that condition. Failure alarms are more troublesome because they usually require periodic testing to make sure the sensors are working and that the correct signals are getting through to the monitor. Some systems are designed to detect problems internally, such as low or dead batteries, loose connections, phone circuit trouble, etc. While earlier nuisance alarms could be set off by small disturbances, like insects or pets, newer model alarms have technology to measure the size weight of the object causing the disturbance, and thus are able to decide how serious the threat is, which is especially useful in burglar alarms. False alarm reduction. Many municipalities across the United States require alarm verification before police are dispatched. Under this approach, alarm monitoring companies must verify the legitimacy of alarms before calling the police. Verified response typically involves visual on-scene verification of a break-in, or remote audio or video verification. Home and business owners can now choose a new type of keypad control panel designed to help reduce false alarms. Based on a standard called CP01-2000, developed by the American National Standards Institute and Security Industry Association, the new generation of keypad control panels takes aim at user error by building in extra precautions that minimize unwarranted dispatch of emergency responders. Some of the features of CP01 keypads include a progress enunciation function that emits a different sound during the last 10 seconds of delay, which hastens exit from the premises. Also, the exit time doubles if the user disables the pre-warning feature. Other rules address failure to exit premises, which results in arming all zones in stay mode and a one-time, automatic restart of exit delay. However, if there is an exit error, an immediate local alarm will sound. Audio and video verification. Alarms that utilize either audio, video, or combination of both audio and video verification technology give security companies, dispatchers, police officers, and property managers more reliable data to assess the threat level of a triggered alarm. Audio and video verification techniques use microphones and cameras to record audio frequencies, video signals, or image snapshots. The source audio and video streams are sent over a communication link, usually an Internet Protocol network, to the central station where monitors retrieve the images through proprietary software. The information is then relayed to law enforcement and recorded to an event file, which can be used to plan a more strategical and tactical approach of a property, and later as prosecution evidence. An example of how this system works is when a passive infrared or other sensor is triggered, a designated number of video frames from before and after the event is sent to the central station. A second video solution can be incorporated into a standard panel, which sends the central station in alarm. When a signal is received, a trained monitoring professional accesses the on-site digital video recorder through an IP link to determine the cause of the activation. For this type of system, the camera input to the DVR reflects the alarm panel zones and partitioning, which allows personnel to look for an alarm source in multiple areas. The United States Department of Justice states that legislation requiring alarm companies to verify the legitimacy of an alarm before contacting law enforcement is the most effective way to reduce false burglar alarms. The Department of Justice considers audio, video, or an eyewitness account as verification for the legitimacy of a burglar alarm. Cross-owning. Cross-owning is a strategy that does not require a new keypad. Using multiple sensors to monitor activity in one area, software analyzes input from all the sources. For example, if a motion detector trips in one area, the signal is recorded and the central station monitor notifies the customer. A second alarm signal received in an adjacent zone within a short to mere is the confirmation the central station monitor needs to request a dispatch immediately. This builds in increased protection and a fail-safe should a door blow open or a bird rattle an exterior window. Enhanced call verification. Enhanced call verification helps reduce false dispatches 25–50% while still protecting citizens, and is mandated in several U.S. jurisdictions, although the alarm industry has successfully opposed it in others. ECV requires central station personnel to attempt to verify the alarm activation by making a minimum of 2 phone calls to 2 different responsible party telephone numbers before dispatching law enforcement to the scene. The first alarm verification call goes to the location the alarm originated. If contact with a person is not made, a second call is placed to a different number. The secondary number, best practices dictate, should be to a telephone that is answered even after hours, preferably a cellular phone of a decision-maker authorized to request or bypass emergency response. ECV, as it cannot confirm an actual intrusion event and will not prompt a priority law enforcement dispatch, is not considered true alarm verification by the security industry. Independent certification. Some insurance companies and local agencies require that alarm systems be installed to code or be certified by an independent third party. The alarm system is required to have a maintenance check carried out every 6–12 months to ensure all internal components, sensors and PSUs are functioning correctly. In the past, this would require an alarm service engineer to attend site and carry the checks out. With the use of the Internet or radio path and a compatible IP radio transmitting device, some checks can now be carried out remotely from the central station. See also, access control, alarm management, door security, dual loop, emergency service, environmental design, fire alarm, glass break detector, physical security, security lighting. References. Sources: Trimmer, H. William. Understanding and Servicing Alarm Systems. Steneum, Butterworth. Weber, Thad L. Alarm Systems and Theft Protection, Steneum, Massachusetts, Butterworth. Walker, Philip. Electronic Security Systems. Cambridge, UK, University Press, Ramsey, Anthony Holmes Security. Schatz, David A., al. Video Safety Curtain. U.S. Patent Number 6297844, issued October 2, 2001. ATS, Anand Kumar. II, N. Clifton. Broadband CSV, XML Alarm Data Standards Auckland NZ, External links, How a Burglar Alarm Works.